The topic of today's video is dividing complex numbers. Okay, so this is what our problems will look like today. So we have a complex number on the top, 3 plus 2i, divided by 4 minus 3i. And the thing about complex numbers is that you never actually want to have an I in the denominator of that fraction. So the bottom part there, we don't actually want the I there. So in order to get rid of that I in the denominator, we multiply by the conjugate. And the conjugate of an imaginary number, so if we have a plus bi, the conjugate would be a minus bi. Okay, if we have a minus bi already in the problem, the conjugate would be a plus bi. So basically, you're just taking the opposite of the imaginary part of the complex number, and then you multiply the top and bottom by that conjugate. Okay, so let's just practice identifying conjugates first. So here are some complex numbers and their conjugates. Okay, so the conjugate of 2 plus 3i would be 2 minus 3i. Conjugate of 4 minus I would be 4 plus I. Okay, so just that imaginary part changes. So if we have negative 2 minus 5i, that negative 2 must stay negative. The only part that changes is the imaginary part. So the conjugate would be negative 2 plus 5i. And if we had negative 3 plus 8i, the conjugate would be negative 3 minus 8i. Okay, so now we may begin dividing. So let's go back to that problem that I showed you earlier. The first step is just to identify the conjugate of the denominator. So the conjugate of 4 minus 3i would be 4 plus 3i. And now we're going to use that. We're going to multiply by the conjugate on the top and bottom of our fraction there. So like this. Multiply by 4 plus 3i on top and bottom. And since we're multiplying, we're going to be using FOIL. So you're going to use FOIL on both the top and the bottom. And this is what you should get once you've multiplied everything out. And if you notice, there are some I squares on both the top and the bottom. So just like we have been doing, we want to replace that with a negative 1 and then multiply that. Okay, so I've already multiplied it. So the positive 6i squared becomes a negative 6, and the minus 9i squared becomes a positive 9. So now that the I squared is gone, we want to combine like terms. So on the top, we're going to get 6 plus 17i, and on the bottom, we're going to get 25. If you've noticed, those i's canceled out. That was the purpose of multiplying by the conjugate. That will always happen when you multiply by the conjugate. You will always just get a whole number, no I in the denominator. So this isn't exactly the way we want to write our answer. Remember, our answers need to be in the form a plus bi. So the way it looks right now, it's not quite there. And the correct form would look like this. You would just divide both of the 6 and the 17i by 25. So 6 over 25 plus 17i over 25. Now once you're at this stage, if you could reduce those fractions, you would want to. But if you guys notice, both of those fractions are already in simplest form. You can't reduce them at all. So that is our final answer. Okay, so let's go ahead and do another example. Make sure you guys understood that. So we are going to start with 4 plus 5i divided by 2 plus 6i. And again, our very first step is to identify the conjugate of that denominator. So the conjugate of 2 plus 6i would be 2 minus 6i. And we would multiply both the top and bottom by the 2 minus 6i. Okay, so remember to use FOIL. Multiply that out and you should get 8 minus 24i plus 10i minus 30i squared over 4 minus 12i plus 12i minus 36i squared. Okay, and again, we don't want to have an I squared, so we replace it with a negative 1 and simplify. And when you do that, basically the 30 becomes positive, the 36 becomes positive, and I squared is gone. So from here we want to combine the like terms, and when you combine like terms, you get 38 minus 14i over 40. Again, there's no more I in the denominator because those canceled out. Negative 12i plus 12i is 0. and that will always happen as long as you multiplied correctly. So from here, we want to separate our answers to a plus bi form to get 38 over 40 minus 14i over 40. Now remember in that last problem, we tried to reduce but we couldn't. But if you notice this problem, we can. So looking at that first fraction, 38 over 40, you can reduce by 2 to get 19 over 20. And then you can also reduce the other fraction by 2 as well to get 7i over 20. So your final answer would be 19 over 20 minus 7i over 20. So I want you guys to try this problem on your own, and I will give you the answer in class tomorrow and we can do some more examples. And that is it.